Hi, Dick Rochford here, aboard the Piper M600.
Romeo Mike, contact Houston Center 132.7.
And we're getting closer to our top of descent,
1582, contact Houston Center 132.7.
which is right there. And for those of you who haven't had the pleasure of flying the G3000 equipment, that should be standard to develop a top of descent, and it's really easy to do. Turns out you probably want to do that either in the climb or right as you get level. And what you want to do is tell the airplane you want to be 0 feet AGL at the airport, and that's the way we do that. 0 feet at the airport at 0 feet AGL. So Garmin takes that 0 AGL and converts it to an MSL. Now then, we want to set the rate, and we can do that in the VNAV window. We want 1,000 feet a minute. So we set that rate. And that computes a target angle, which only jets really care about. We don't care about that. And now then we can do one of two things. When we get pilot's discretion to some altitude, we can put the altitude in the window. We've already done that, 240. And then arm the VNAV. And the VPath comes up in the marquee as armed. When Betty sees us getting close to our 1,000-foot vertical speed required, she says vertical track, the carrot centers, and down we go. If we don't have PD, and at this point we do not, don't light that light. That way nothing will happen. On the other hand, if we finally get a descend and maintain flight level 240, we dial in 240, and then come here to VNAV direct. Enter. That'll center the carrot and get the descent going. There are a couple other ways to descend, but nothing slicker than that. Of course, you can do an a long track offset for pilot's discretion using the same technique. And then all we would do there is, instead of putting it in as the waypoint, we build the waypoint 30 nautical miles northeast or whatever at whatever altitude, and put that in there instead. The other quick and dirty way to descend is with the VS and flick. Now, no matter how you descend, it's going to be important to control airspeed. It's best to use VS or VNAV in the descent so that you don't get behind on that descent task. Flight level change, or IAS as it's labeled in some autopilots, is the ability to climb at a particular airspeed. Now the difference is we want to climb with airspeed and descend with VS. And the reason is we need to control our exposure at high speeds to turbulence in the descent. We do the same thing in the climb with VS, or correction, IAS, or Filch as it's affectionately known in the M600. By climbing at 130 knots for the second segment of the climb. And to be clear, first segment is the dirty segment, and we're obligated as professional pilots or professionally trained pilots to climb at VX if you have obstacles, clear the obstacles, and then get to second segment climb as quickly as practicable. If you think about that, that's going to be no delay on gear and flaps. I see people hold their hand on the handle until the fuel truck's gone or the runway's no longer visible, or I don't know what all that's about. You have an engine that's 100 times more reliable than just about anything else out there. So when it comes time to end the first segment climb, note positive rate of climb, get the gear up, get the flaps up, trim the airplane, and put it on the autopilot. Be quick, but don't rush. Now then, once you're in the second segment climb, which you are once you're cleaned, consider a 130 knot climb with IAS or filch so that you maintain proper speed whether you're in airframe ice or turbulence or anything else for that matter. But this is where those two important speeds cross. They cross around 130 knots. Now, I'm not being picky with max gross weight versus takeoff weight. I'm not talking about any of that. Just 130 knots. Keep it simple. VA and ice penetration speed. It's a beautiful thing. Once you're in the habit of doing that, you'll have the confidence to move on, having done your proper pre-flight planning. Now, once you clear the weather and you're out in clear blue sky with no threat of turbulence or airframe ice, then next thing would be your fourth segment climb. Turboprops don't have a second segment climb, correction, a third segment climb, because we don't have to level off and burn fuel before we climb higher. We don't go that high. And so fourth segment climb is something between 110 and 140 knots that meets your mission with respect to wind speed and direction and how much fuel you want to burn or not burn. And as you probably know, turbines operate more efficiently up high. So getting up high quicker is profitable. Today, not so much. Over 100 knot headwind. That actually started as 120 knot headwind. So we're actually making more progress than we did before. So there's the wind. Here's the true airspeed, 260. Outside air temperature, minus 37. And a ground speed of an embarrassing 160 knots. This is a training flight, so after we land, we're going to get fuel and turn around and come back, at which point we'll probably be doing 350 over the ground. It'll be sweet. Dick Rochford, fly safely. Train often.